Hi, Assalamualaikum. Today our group will present to you about Lab 7, which is System Response.
In part A, first the value of k is assumed from the range of 1 to 10,000. K was assumed as 2000 and replaced in the transfer function equation for the third order system shown in the lab sheet. And the equation need to be normalized to obtain the value of s plus 1. To get starting value for the plot for the magnitude graph is need to use the formula 20 log 2000 per 500. Where 2000 is the value of k, while 500 is the range number of the normalized equation. The starting value obtained is 12.04. To obtain the plot, the value of the denominator s is taken as a guide point for the graph, namely 2, 5, and 50. At point 2, the height is negative 20 dB. At point 5, the height is negative 40 dB. And the last one, at point 50, the height is negative 16 dB. And the block plot magnitude graph will be formed. For the block plot phase graph, the value of 2, 5, and 50 need to divide by 10 to get the new point. The new value are 0.2, 0.5, and 5. The graph is static at 0, line on the y-axis. Point 1, the height is negative 45 degrees. At point 2, the height is 19 degrees. At point 3, the height is 135 degrees. At point 4, the height is negative 19 degrees. At point 5, the height is negative 45, and the last one, the point 6, the height is only 0. By using the phase graph, the value of the gain margin can be obtained by drawing a horizontal line at a value of negative 118 degrees and ending when it collides with the phase graph. At that point, an upward straight line is drawn, then connected by magnitude graph. Then a horizontal line is drawn at the point of collision on the magnitude graph and will obtain a gain margin value of negative 17 dB. To obtain the value of phase margin by using magnitude graph, draw a horizontal line at 0 dB so that it collides with the magnitude graph. From the point, a straight downward line is drawn and connected to the phase graph so that it collides with the phase graph. At the point of collision, a horizontal line is drawn and the value of the phase margin is obtained, which is negative 119 degree.
Hi, my name is Nurizati. Now I will explain to you how to obtain the range of K for the stable system. The range of K will determine by using gain margin and phase margin that obtained from the dot plot. The gain margin we obtain from the dot plot is 17 dB. While for the phase margin, we need to do some calculation. Phase margin is equal to negative 119 degree, which we obtain from the dot plot, minus with negative 180. So the phase margin that we obtain is equal to 61 degree. The value of K when the system is stable is the gain plot when the phase is from 0 degree to negative 180 degree. Therefore, to obtain the stable value of K, first we use the formula 20 log K over 500 equal to the gain margin, which is 17 dB. And then we rearrange the equation, which we get K is equal to 500 and T log 17 over 20. And then we get the value of K is equal to 3540. The range of gain K that the system would be in stable stage is K is greater than 500 but smaller than 3540.
Hi, my name is Ilya. In part 3, MATLAB software is used to generate the dot plot of the system that has been given in the lab sheet. The magnitude and phase transfer function was generated to find the dot plot. The numerator and denominator of the initial transfer function were defined to find the transfer function. This is the command to put the value of k in the command window. There were two parts to calculate the margin in the coding. The first part is to calculate the gain margin, and the second part is to calculate the phase margin. The command of the value frequency in the gain margin was set to 180 degrees, meanwhile the value of the phase margin was set to 0 degrees. The GM of the gain margin has been adjusted to 20 times log 10, 1 over mi, while the value of PM in phase margin is 180 plus pi. After all the coding has been run, the value of k was set to 2000 in the command window to obtain the Bode diagram. This is the Bode plot of magnitude and the Bode plot of phase. The gain margin that has been calculated was 70 dB, while in simulated is 20 degree. The value is different, however, it is almost identical. The value of phase margin in calculation is 61 degree, while the value that has been simulated is 59.4 degree. There was a delay in the phase Bode plot. Both magnitude and phase were stable. That's all from us. Thank you.